Hello, everyone, and welcome to this week's Cribl weekly demo. It's going to be on routing, replay, and redeliver, a tongue twister for me, so bear with me. Before we jump in, I just wanted to take the time to introduce myself to those of you that I haven't met. Let me turn my video on for this part, actually. I am Desi Gavis-Hewson, and I'm the Sales Development and Sales Enablement Lead here at Cribl. Previously, I led the national sales development team at a co-working company called Industrious. And then before that, I was on the sales team at an ad sales enablement company called Media Radar. I also built out the sales development team at Trello. So my path to Cribl is a little non-traditional for sure. My background's not in logging or this industry. And I've been in a few different industries in my career as well. I think ultimately, though, it's kind of a no-brainer for me to come to Cribl just because I love and I am good at matching people with tools that give them just more flexibility and choice in their business. And that's what Logstream provides. So lovely to meet you guys. Here's what to expect on today's call. So almost every week, we'll be doing a demo of Cribl Logstream and walking through specific use cases within the product. So first, I'll do a quick intro to observability pipelines in general and Logstream for those of you who may not be as familiar with us or what we do. And then from there, we'll move into a full demo of Logstream. We'll talk through the specific use case for that week. Obviously, this week, that's going to be around routing and replay. And then you'll have the opportunity to ask some questions of me regarding the product after that. So global data is growing at a 25% compounded annual growth rate. I think everyone in the world understands that to some degree. So take being in a global pandemic, for example, rather than those meetings that we're having at work happening in person, they're happening where? On Zoom, right? So Zoom's generating data. So even if you think about it from a non-technical perspective, it's really easy to see data is growing astronomically. By 2025, enterprises are going to be managing 2.5x more data than they were in 2020. So the amount is growing, but there's another problem. Logging systems are already at capacity. So I talk to enterprises daily with costs in the millions when it comes to licensing. And then on top of that, you get inadequate data retention sometimes in organizations. When your logging system is reaching its limits, a lot of people believe that they have no choice when it comes to dropping data that they'd like to keep around. And then kind of going back to the licensing costs, the infrastructure required to store this growing set of data can cost as much or more than commercial licensing costs. More data also means you need more CPU dedicated to analyzing it, right? And for many customers, the added infrastructure costs can be in the tens of millions of dollars. Lastly, environments are getting super complex, right? You have your time series databases, your data lakes, your cloud data warehouses, and each of those has its own agents and its own ingestion pipeline, right? It gets tough to manage it all. An observability pipeline solves all of these problems, and our product, Cribl Logstream, helps teams implement an observability pipeline without replacing any existing tooling. So with Logstream, you can route data to multiple destinations, including cheap object storage. So this is ideal for organizations who have multiple teams and different tools that maybe all need the same data, or for anyone looking to cut licensing costs by leveraging cheap object storage. You can replay data from that storage. So once it's there, you can get it back at any time. And that's actually what we're walking through today. You can reuse investments in data collectors for new use cases, secure contents of your data. You can enrich that data in flight with key additional context. GeoIP enrichment is a common use case for Logstream, just to name an example. And you can also move workloads from batch systems to the stream, which reduces some of the infrastructure needs that we were talking about before. So the first thing that an observability pipeline does, right, is act as a universal receiver of machine data. So a universal receiver consolidates handling of any industry standard protocols like a syslog, right, receiving HTTP traffic directly from applications, and receiving data from metrics agents and log shippers. The next thing that it does is act as a universal collector. So in most enterprises, collecting data from data lakes, event buses, or from other log analytics systems are really bespoke pieces of software with limited connectivity. They're often built for one particular data flow. An observability pipeline really allows you to collect data from APIs or from other destination systems, perhaps that maybe the pipeline initially delivered to. An observability pipeline allows you to connect any of our sources to any of our destinations. So this allows us to send APM data to a log system or collect from a data lake and deliver to a time series database. So observability pipelines also allow us to insert kind of in the middle to redirect data to a more cost-effective system of record, by storing full fidelity data in cheap object storage, like AWS S3. We can onboard all of the data into our data lake. And then from our system of record, you can then replay the data at any time into any system of analysis we want, like a log analytics tool, data lake, or time series database. And then lastly, from LogStream's position in the middle, we can easily eliminate any noisy data that provides either little or no value in your log analytics tool or time series database. So there are a number of things an observability pipeline, though, must address above and beyond just reliable delivery of data. Protocol support, right? It needs to work with existing deployed agents. It's got to receive from industry standard protocols. It needs to collect from your existing observability or security systems that you've already set up or established. The second thing that is often required is there are a lot of data shapes in organizations, right? A lot of it looks differently, or it's some of it might be unstructured. Logging systems have tens of thousands of data shapes and formats, and it often needs to support many nested structures as well. And then the last thing is scale. A typical event streaming pipeline is going to move terabytes a day. So when you're getting into the 100x or 1000x, as far as talking about your log pipelines, right? They're way larger in scale, petabytes a day in large enterprises. They need to support, in some cases, hundreds of thousands of endpoints. So it just gets really complex and it's hard to scale it. So in these three respects, it's a little different than pure event streaming, which is a question we actually get a lot. So if you forget everything else today, please remember this. Cribl LogStream helps implement an observability pipeline to route security of machine data where it has the most value. We're going to help you slash costs, improve performance, and get the right data where it's needed in the formats required. And with LogStream, you can actually reshape, reduce, or route the data so that you remain compliant, right? If you need to keep the data around, you can route it to the most cost-effective destination possible. The idea is to help you optimize your data, whether that be in storage and performance, or however you can. So next, I want you to see the product. I had my colleague Mo Hassan from our Solutions Engineering team record a walkthrough of Cribl LogStream, and I will play that now.
Thank you for joining this webinar. Today, we will be discussing the Cribl LogStream product, and we'll just have a product overview. And then we'll focus on the replay feature. All right, let me just enlarge my screen here so you can see it better. All right, so here's what we hope to do is we're going to do introduction, no discovery, obviously, and then we'll discuss the highlight of the product and the architecture and maybe hands-on demo. Those are the logos that we come support out of the box. So Cribl LogStream, as you might know, is an inline processing engine. It sits between your sources and your destination. And whether you're dealing with cloud services, you're dealing with push-based, pull-based sources, Splunk, Elastic Beads, Splunk Signal Effects, FluentDM, and you can see the bunch of logos here. We also do several file formats, all the file formats under the sun, XML, JSON, CSV. We can do translation. And we accept raw TCP, So we'll cover that more in details. I just want to go over quickly overview of the product here. Question keep coming up all the time. What is Cribl log stream? Simply put, it is a layer sits between your sources, and this is only showing 3 sources, but we support a lot more than that, and your destinations. So and we do the processing in the ingestion pipeline itself. And when I say processing, we're talking about redaction, encryption, routing, and we'll cover more of those details in a second here. Here's a little bit more deeper view of the architecture. Basically, on the left, you have the sources. And again, as you've seen earlier from the previous screen, we do a lot of support for multiple sources, and namely the big ones, Splunk and Elasticsearch. And not only that, we accept syslog, we can pull data from Kafka, from S3, from Amazon SQS, Kinesis, Microsoft. I mean, it list goes on and on and on. The data get ingested into Cribl log stream, and the reason I have this slide here so we can help you understand when we go to the demo, we have concepts called routes and pipelines. Every route has at least one pipeline attached to it. When you hear the word route, think of the filter. If route is a way to pinpoint the data coming to the product on the stream side, on the ingestion side. The pipeline is how do we handle this data? What do we do with it? How do we reshape it? And obviously the destinations are inverse of the previous of the sources. Again, it's just the same thing here, but this slide here is breaking down the architecture, but saying basically we have worker nodes, and those can be grouped together, you know what I mean? And then they're all talking to a master node. Master node does not do any data processing. Basically, it coordinates the cluster behavior, if you will, share bundle data, that kind of stuff. One of the things that I like to highlight to the product, and it's we have something called persistent queues, where if your data in the left here is if your destination's down for some reason, your Splunk infrastructure cannot be reached or down for maintenance or whatever, we have the feature called persistent queues, where you can actually let log stream store data temporarily until your infrastructure or your login solution comes up again. We have built-in regex editor, and we have revision control, which is GitHub support out of the product. The concept of worker groups, as I said earlier, the worker nodes where the processing is happening can be grouped together. And why would you want to group those together? An example here is if you have multiple providers of cloud providers like Microsoft or Amazon. So as you guys know, the providers will charge you for egress charges. So pushing or installing the worker nodes or worker groups closer to the sources in the cloud. So this way, all the reduction and the compression happens before it reach your on-prem or anywhere else. So this way, when the data leaves your cloud instance, it's actually reduced, and therefore you're reducing the ingestion charges. The other use case, common use case, if you have remote offices and let's say you have a smaller office somewhere with a weaker link, and you're doing a lot of Splunk maybe or Elastic sources coming out from that smaller office, and having worker node closer to on the small office itself can actually reduce your footprint on the link and the stress. Those are two major use cases for grouping worker groups together. The major feature, which is a discussion here today, a topic of discussion, is actually the replay feature or data collector. As you've seen before, data comes in from the left and it gets processed in events. One of the things you can do to the data stream is actually archive it, or you can just process it with a bunch of functions that we're going to discover later. So archiving can happen to S3 buckets or any S3 compliant like MinIO. It can happen to through a REST API. It can happen through NFS mount, or you can write your own script if you wanted to. So imagine this thing, data comes in, and I'm going to split the stream. One goes to Splunk. The other one goes to my S3, which is really cheap storage. So you can keep the data in Splunk for a week, 30 days, whatever retention policy, but then you have continuous recording, infinite if you wanted to. The use case we talk about here, a customer with, I think, 10 terabytes or something like that, and they were able to save $1.3 million by utilizing very, very cheap long-term 1-year retention on S3. And once you really need the data, and this is for security investigation, obviously, or other things, but security investigation seems to be a common use case here. But if, let's say, you want to get the data that's a year ago, all you have to do, go to the UI in Cribl log stream and re-ingest that portion of the data into your login solution. So you basically have your cake and eat it too. You have your immediate data available for quick searches in your login solution. Yet, if you want to keep high volume, low value, like NetFlow, for example, and you can actually store that in S3. A lot of my customers actually will have continuous recording, split the stream to S3, because S3 is really dirt cheap. It's extremely cheap, and there's no reason not to be able to utilize that feature. We'll cover that in the UI in a second here. Examples, again, if you're existing a log stream user, you're probably familiar with those, but if you're new, I just want to highlight what can we do with the product. We can do, this is the reshaping of the data I was talking about. We can do reduction, we can aggregate. We actually act on events and on source types or metadata like source type or host name or IP address. So things we can do is aggregate the data. We can drop the event completely. We can sample the events. We can do dynamic sampling. We can change logs to metrics, and the advantage is obvious there. We can suppress the events if you wanted to, and the archiving and the actual tangible dollar where you can actually measure it is if you can actually route data to multiple destinations. So let's say you're using Splunk today, tomorrow you're going to use something else. You want to investigate different login solution, you can easily do the migration with the routing feature. Again, as I said earlier, it's not just S3, it can go to regular FS file-mounted system. We also enrich data inline. We can do CSV lookups or GUIP or DNS, just regular lookup stuff. People might ask, why would I want to do a lookup on inline versus data at rest when it hits Splunk or Elasticsearch? There is an advantage to that, especially when doing security investigation. Let's say you're mapping IPs to host names. You really want to do that mapping at the time of incident, time of ingestion, not a day or a week later. In a DHCP scenario, or sometimes the host and DNS names and IPs are fastly changing, and so it's critical that you actually map them together when it happens. The same thing happens for logged in user to a system. So there's an advantage of doing lookup at the time of incident versus hours or days later. There's some security functions also. We can encrypt fields and we can mask fields. Again, it can be done in the login solution, obviously, but doing it in the stream, you're actually guaranteeing that nobody, by the time the data gets to Splunk or Elasticsearch or Kafka, whatever it is, it's already encrypted. So there's no room for tampering. Formatting, and that's where we get the concept of what we call ourselves universal or a schema agnostic. Imagine this thing, it doesn't really matter where's data coming from. So you can have universal folders, Splunk universal folders in the raw format, and they can change the data to Elastic Common Schema, which is JSON, and then from your UF, you send it to Elastic, or vice versa. You can have Elastic beats with JSON formats and send it back to Splunk when we do the reformatting in the process. We can flatten the data. We can translate the data from CSV to JSON back and forth. You can reserialize the data. I mean, there's a bunch of other functions that if you're a regular customer of the product, you're familiar with. But this is really the power of log stream. It's just the fact that gives you great control over what you can do with your events before they get to your login solution. Okay, we've covered that. Let's get to the demo. And I'm going to focus. Here's a demo. When you first log into Logstream, you'll see this screen. So you'll keep track of time. Obviously, we have sandboxes. You can I recommend that you haven't played with it, to just go ahead and it's a guided tutorial. You can just spend 45 minutes, an hour. It will tell you how to do reduction, how to do enrichment, that kind of stuff. So We also have a bunch of blogs, bunch of videos. So there's no shortage of information trying to learn the product. One of the things you can do when you log into Logstream is to get in the monitoring console or the monitoring screen, if you will, here. Basically, it gives you statistics and aggregation of what's happening, how many events per second, how much data in, how much data out, and then a bunch of information about your host, basically the health of the host. It's good for troubleshooting. Not only just aggregate view, you can actually drill down to by sources. So I can look at my sources here. I can tell you this particular source is kind of working, this one barely working, this one is very jaggedy, and then again, the in and out. And the same thing can happen for destination. Also, if you're familiar with the product, you've heard the term routes and pipelines. And so there's another way to get an insight how much data being processed, APS, and total data in and out. Again, great for troubleshooting. So how do we, so in this particular environment here, we have multiple worker groups defined, and we have one called logs here. So when you first go to the worker node, again, you see tabs on the top here, and data, and the defined destination sources, and the collection feature which is replay, or you can define your routes, again, filters. How do I zoom into my data coming into the pipe? And then pipelines, which is how do I process this data? Example of a simple use case, this particular one here, it's data called trim big JSON. By the way, these things can be moved up and down if you want to change the logic. So I have a one called archival here, because this is really the focus of the discussion today. Archival is saying when the data comes in, and route name is archival, filter is true, which is mean I want to apply this logic to all the data, all the streams, everything. And then pipeline is pass through, which means do not do anything to it. And then output is going to be S3. And by the way, it doesn't have to be S3. It can be, can be any other destination or anything that you defined in terms of destination. So let's focus on the enrichment use case. Trim big JSON is one route name, and this attached to this pipeline or the output, if you will. If I click on it, and it's gonna send me to this tab, the pipeline tab, and expanding. Obviously, everything would have a comment. If I expand the tab to see what am I doing here, basically I'm zooming into a source type called lambda, and then I'm applying a function called serialize. The functions that we have at your disposal coming from here, and as I said earlier, you can do aggregation, sampling, dynamic sampling, and masking, all the good stuff that we mentioned earlier. One cool feature about this product is now I have my pipeline defined, if you will. I can sit here and say capture view, and it's going to use this filter expression. By the way, we use Java expressions, JavaScript expressions. And if I do capture and ask me, you want the first 10 seconds or first 10 events, either way, it doesn't really matter. And the system will actually start, it's like sniffing, if you will, and capturing data coming in as it comes into the stream. And there we go, this data comes in. And if I look at my data here, I can tell you that this one header here and multi-value headers, those are duplicate of each other. And my task here is to remove one of them. So I can save this data, and I have it now. And here's the pipe. Here's the data the way it came in, that I captured, and here's what happened to it. Look at in and out. Here's what happened to it when I actually applied my pipe to it. And in this case, I did some reduction. And if you can see, multi-value headers grayed out, because I said 20 items here, headers, 20 items were duplicate of each other, and what we did here on the left says we dropped field to remove. We're going to drop this multi-value header, which is this guy here. The impact of this change is actually as 44% reduction in your data volume. Obviously, the developer of this code decided to duplicate the data for some reason. So, and there's so many tricks and things you can do like that. If you look at the data, I mean, simple syslog, and if you can remove a few bytes from an event and you have high volume of this data, you're talking about gigs and gigs. If you have 10 terabytes, and I can save 5% of this particular file, this particular source, that's significant. Again, operational mode can be serialized, it can be extract, and JSON, or the type of the file that we're dealing with here can be CSV, extended file log format, key value pair. Those are the formats we understand out of the box, if you will. There's something else we can do here. This one here, filter expressions. Basically, we're saying here anything with value null, I also want to drop it. And that's one example of how you can do a reduction of data. Let's talk about a enrichment of data. Pipeline, or the route called firewall Palo Alto. Again, it's just basically what it's doing here is source type. I'm just focusing on the first source type to pinpoint the data. By the way, the routes here get sequential execution. So it starts from the top, we go to the next one, 3 and 4 and 5. If you want to stop that execution, all you have to do just toggle this thing, says final yes or no. If it's set to yes, it will not go to the next step and it will actually exit. Basically, it's like a break statement in a loop, if you will. This is my route called Palo Alto Firewall, and this is the pipe attached to it. If I click on that, let me just collapse this. If I click on that one, as I said, showed you earlier, we can do capture, or we can actually use the sample files already being captured, or you can actually manually import or cut and paste if you wanted to. So looking at my sample input from Palo Alto or PAN traffic data, this is the data, and this is what happened to it after it leaves. What we're doing here is actually, first we do the reduction, the extraction. So we did a bunch of functions here, and basically, since this data is, if you can see field, comma, field, comma, field, comma, it's not key value pair. So you have to know the schema ahead of time for this particular file type. In this case, it's published. I mean, you can find it from Splunk, you can find it from Elastic configuration, you can find it from the vendor itself. So I know the fields, and I'm going to apply this schema, if you will, to those fields. Now they're being extracted for me. So now they extracted the field, things I can do GUIP lookup. Let me collapse this thing so it's easier to read. I can do GUIP lookup. So what I did here, anything with source underscore IP and destination underscore IP, we are going to apply GUIP data, and it's going to be, we're going to add a field called source underscore GUIP. And if you look at my data here, see those fields here, those are added fields, basically a GUIP data, city, country, latitude, longitude, all that stuff. So this one way of enriching data. This is actually not reducing data, it's actually enriching data. So you're adding more to the size, but again, it's an option for you if you want to enrich data in stream. The enrichment doesn't happen only on lookup or GUIP. You can do it against regular DNS. So in this case, source IPs, and I translate them to this field name here. So, okay, so source underscore IP, source host name, or I can do the same thing with destination, actually. Yeah, so here's the source IP, and here's the destination host name that I was able to look up on the fly from a lookup table. Again, the same thing applies to the other IP. The lookups also can happen against CSV files, and we do support CIDR notation if you have your network segmented and non-standard ABCD, you know, like /30, 31, 29, things like that. We can actually support that too out of the box. And in this case, we are zooming on source IP or location, and we're able to pinpoint the IP based on or lookup file, and just particularly says, yeah, this particular IP coming from HomeNet. Let's see if I have an example here. Yeah, there we go. So this is a source IP 192.168 and subnet usage, or this is based on my data and my lookup file. I was able to say this guy is coming from his home. So because I call it home worker net. Those are the two examples of the enrichment and reduction of data. Another one quickly here that seems to be very common, masking data, sensitive data. And I have an example of the sensitive data file, if you will, and then data in, and this is what happened to it when it's really redacted or encrypted. I have to actually go to the, and go sensitive data. Where is my sensitive data? There we go, there it is. and this data in, and here's what happened to it when it came out. If I look at the function that was added, again, I remember there was a bunch of functions here you can pick up from, and masking and encryption is one of them. This is, I want to show you the regex editor basically built in. So what I did here, you can actually add your regex here. If I do the editor here, and here's my sample event, and this is the regex to detect the social security number, and this is the Java expression, replacement expression that I did, and it shows you on the fly, this is my social security before, and that's how it looks like after it's been MD5 hashed. Again, it doesn't have to be MD5, it can be encryption too. That is a simple, and here's a crypt function that we apply in versus mask, so be aware of that. We also support every time you do a change, we have a built-in GitHub, or you have to install GitHub in your environment, or you can use your existing Git repository if you wanted to. Okay, so that concludes the discussion for the product overview, and thank you.
All right. Share and reshare. Amazing. So you guys just saw essentially a few general applications of Logstream, right? But let's get a little bit more specific. So I mentioned before that Logstream helps teams to cut costs and to stay compliant. Placing a log stream deployment essentially between your logging sources and your log analytics system allows you to archive all of the data to a cheap storage mechanism for retention, and then replay it or bring it back into Logstream for redelivery into another tool. So this has a ton of applications, including streamlining a breach investigation, right? Not only do you save money on retention, but leveraging Logstream also lengthens the amount of time that you can keep data around. And then it allows you to filter for only what you need as the data breach investigation progresses and the scope of the breach becomes a little bit clearer. So here's another video from Mo to show you exactly how that is done.
Okay. Thank you for joining this webinar. Today we'll discuss the replay feature or the collector feature of Cribl Logstream. As we mentioned earlier in the previous session, the replay feature allows you to save money, tangible, measurable money. Basically, you can split your stream, incoming stream, and have some of the data or all the data go into a cheaper solution like S3 or local mount NFS. And the way you do this, basically, here's what happened. We first log into the Logstream. If you go to the worker groups and you zoom in your active worker group, and I have a route called archival here, and that says here, data comes in. I want to set filter to true, which means don't set anything, just capture everything. You can be specific here if you wanted to. So if I want to archive only Palo Alto data, I can do that. Or I can just archive. In this case, I'm going to archive everything else. The pipeline is passed through. I want everything, and then my destination is going to be S3. So this here, the output is something you define in this section, collectors. And if you can see, I have a data collector configured here, but I can add my own if I want to. You can have to create my collector, or I can call it a fast collector if you want. Doesn't matter, So when you choose the type, again, it can be a file system, an FS mount, can be a REST API call. So your Logstream will make a REST API call. It can be a script that you write, so you can send it to Kafka if you wanted to. Or the most common one is actually the S3. So we don't want to define that. I just want to go to the existing one. It says S3 collector, and again, collector ID. Every configuration you do in the product must have unique ID. And the type is defined as 3. But here are the things that you can do. Obviously, you can write a script, or you can do a Lambda function to do the same thing, but the product has built-in functionality through the UI. You don't really have to worry about writing anything. If you're using S3, obviously you're going to change. You configure things that relevant to Amazon. So you specify the region, and we specify the API key, the security key, and we support also AMIs. One thing I want to draw your attention to, this one here. This line highlighted, it's telling the log stream how to format the data in the file system when it landed to S3. So when the data comes in, log stream will write this data in this format. It will do a timestamp first. It will then do a slash source type slash source zone slash source IP destination or source destination. Why would you want to do that? The more structure you can add to your data, the file, the directory structure, if you will, the faster it is to retrieve that data if you wanted to. So just be aware of this path, and when you're defining incoming data, let's say once data to your S3, you can actually also define the path there. So let's assume this is a data structure that's sitting in our S3. There are a bunch of other advanced settings, if you will. In this case, in this configuration here, it says min.io, local storage, local S3. Doesn't have to be Amazon, as I said earlier. Other things, you can actually execute custom commands before you run the script. So if you want to do some cleanup, any tuning, if you wanted to do the data, you can do that. Event breakers, by definition or by default, the assumption is when you send data, when the data comes in, you can apply event breaker, so it's already set. But if you're reading data from a source or from a lake, if you will, or S3 that hasn't been set by Logstream, some person just like, here's my S3 data, go look at it. You can actually apply event breakers and time anchors and all other stuff. Again, if the data coming from Logstream, that's probably already there. If not, you have the option to add your own settings for event breaking. You can also assign meta fields if you wanted to the data. So what happened now that I have my collector defined? It's really simple to get the data from Logstream from your S3 collector. You have to just hit run. And then you can specify the mode you want, just preview only. Basically, I just want a sample data. Don't give me everything. Just want to make sure I'm getting the right data. Or you can do discovery, where you can say, what is out there? Let me just discover the fields and the files out there. Or you can just run full run, and that's when really actually going to bring the data. And the speed here is a function of how much data coming in, how well structured the data, and actually other things. So the speed of your storage and a bunch of other things. So if I just want to do a preview, I can you can just specify the dates. And if I say I want the data from the 27th, and you can specify timestamp actually, which is date time. And I want to specify this, and from this day to this day. And I have my date range. And not only I can use the timestamp as a way to get the data, but I can actually get deeper specific. So this settings here, the filter says true, which means get me everything. But if I want to be very specific, and if my data already extracted and the directory shows source IP, I can say, yeah, source IP, and give me the data only for 192.168.1.1, for example. You can be that specific if you wanted to. So just don't have to spend hours and hours getting the data. Just go to the directory and instruct Logstream to go to the right directory right away. And again, those are tricks that you can actually do. And by the way, the filters are Java expressions, so it's kind of cool, and utilize the power of Java expressions. You can do other advanced settings. So if you have other information that's captured in the directory name, the log, well, actually in the actual data, you can say, like, I just want the log level in case of syslog data. You can specify the bundle size. And upper size. So you can specify the do I want to do the data before the pipeline process as if there are two pipelines, there's pre-processing and post-processing, a bunch of other pipelines. So you can get the data before pre-processing pipeline or after. Before the pre-processing pipeline or before the routes. Anyway, so now I specified my range and timestamp, and I said I want everything, and I hit run. And it's simple. Now it's going back to my infrastructure and going to my S3 and pulling that data in. and voila, there it is, so, and I can just save the file if I wanted to. It is as simple as this to get the data from S3. As I said earlier, it doesn't have to be S3. It can be a simple file system, NFS mount or local file system. So the other thing you can do with the collector is actually schedule an event. So I can say configure here and enable, and then you can specify when do you want this data to come in. I mean, there are a bunch of use cases for this thing. If you have like a batch processing, if you will, when you get segment of data, let's say someone is sending you data on a regular basis, and you know the timestamp around it, so you can say every day from 1 to whatever, and give me that segment of data. So it's one way of doing it. Or if you're doing your own script, so assuming this is not just S3 data, this is not something came from an S3 source, it's came from something else, you can actually use that as a way to schedule it, the collection, if you will. And as you can tell here, for those Unix guys, this is just simple cron job configuration, and it's a nice feature to have. So that concludes the demo for S3 collector, or the collector.
Amazing. I'm just trying to switch my share here. Okay, great. And that's that. I am happy to take any questions that y'all have at this time. So please use the Q&A feature here in Zoom to do that now. I will wait maybe 30 seconds to a minute. And then if there are no questions, we can just end early. But yeah, let me know if you guys have any questions using the Q&A. Thanks. Okay. I see one in here so far, so I'll answer that one. They ask what options does Logstream provide around configuring the info to filter? Okay, so less about replay, but I'll answer this one. In Logstream, you can use a simple filter expression to reduce the data that's going into your analysis tool. So all of those filtering options can be configured based on meta info, any meta information such as host name, source type, or log level, like we saw the demo, or by content extracted from the event, or both. So it's actually really flexible in that way. There are a number of different ways that you can filter. All right, and I don't see any others, so I will go ahead and end the webinar. If you guys do think of any other questions afterward, feel free to reach out to me at any time. I am just Desi, DESI, at cribl.io. I'm happy to answer any questions that you guys may have. Otherwise, I hope 2021 is off to a great start for you and yours. Have a great rest of your week. Talk to you later.